Welcome to tonight's video on Unit 8, Part 1. We're going to talk about the geometric mean. And the geometric mean of two positive numbers is the number such that when you do the cross product, that a over x is equal to x over b. So basically, x is equal to the square root of a times b. So for example, here it says the geometric mean of 9 and 4. Well, if you do x over 9 equals 4 over x, cross multiply, x squared equals 36, x equals 6, because it's the square root of 36. So that's how you find the geometric mean, is basically you take the square root of the two numbers. So here, find the geometric mean between 2 and 50. So you would say x equals the square root of 2 times 50. So x equals the square root of 100. So x equals 10. The geometric mean between 3 and 12, well, x equals the square root of 3 times 12. X equals the square root of 36. So x equals 6. All right, so now some theorems that use the geometric mean, and that one of them is if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle. So notice there's a small and a big triangle, and those are both similar to the bigger triangle. So if you want to write a similarity statement identifying these three similar triangles in the figure, you could say triangle EFG, which is the bigger triangle, is similar to triangle EHF, which is the small one here, which is similar to triangle FGH. So those are the three similar triangles in that picture. So if you're looking at the next picture, triangle LMN would be similar to triangle LOM, which would be similar to triangle MON. So the main thing is that if you draw an altitude to the hypotenuse of a right triangle, that you're going to create three similar triangles. By creating three similar triangles, you also create proportional parts, which leads to the fact that an altitude is the geometric mean between the segments of its hypotenuse. So, for example, any altitude drawn here, h, is going to be the geometric mean between x and y. If it's a leg that you're looking at, so like A and B are legs of the right triangle, then the leg is going to be the geometric mean between the segment closest to it on the hypotenuse and the whole hypotenuse. And that's what theorem 8.3 says. So to review here, it's basically saying P is the geometric mean between Q and R. So any altitude is the geometric mean between the two segments on the hypotenuse. If you have a leg like T, it would be the geometric mean between the segment closest to it, which is Q, and the whole thing, which is U. And for S, it would be the geometric mean between R and the whole thing, U. So now let's do some examples. So here it says to find C, D, and E. Well, E is the altitude. So E would be the geometric mean between 6 and 24. So E is equal to the square root of 6 times 24, which is the square root of 144, which is 12. Now for C, it's the geometric mean between the segment closest to it, which is 24, times the whole thing, which is 30. So it's equal to square root of 720. And now we'll talk about this in a little bit, but simplifying square roots, well, this is the same as the square root of 144 times 5, which gives you 12 rad 5. And for D would be the geometric mean between 6 and 30, so that's 180, which is equal to the square root of 36 times 5, which is 6 rad 5. So here's the next thing for number 6, to try to find E and F. Well, E is a leg in the big triangle, because here's the right angle. So E is equal to the geometric mean between 16 and the whole thing, which is 20. So 16 times 20 is the square root of 320, which reduces 320 can be broken down to 64 times 5, which gives you 8 rad 5. For F would be another leg, and that's going to be the geometric mean between 4 and 20. And 4 times 20 is 80, so that's 16 times 5, which is 4 rad 5. All right, so the next one says Miss Alspach is constructing a kite for her son. She has to arrange 2 support rods so that they are perpendicular. The shorter rod is 27 inches, and the longer, if she has to place the short rod 7.25 inches from one end, so that means this part here is 7.25 right there. In order to form 2 right triangles with the kite fabric, what is the length of the rod? All right, so for number 8, it's the geometric mean between 9 and 13, so it's 9 times 13. The square root of 9 is 3, so 3 rad 13 is the geometric mean. So for number 9, you have x equals the geometric mean of 2 rad 5 times 5 rad 5. 2 times 5 is 10. Rad 5 times rad 5 is 5. So it's equal to the square root of 50. And the square root of 50 is 25 times 2. So that's equal to 5 rad 2. All right, for number 10, A is an altitude. And so it's the geometric mean between 8 and 3. 8 times 3 is 24. 24 is equal to the square root of 4 times 6, which is equal to 2 rad 6. Number 11, to find x, you do the geometric mean here, and remember this is 16 if the whole thing is 20. So x is equal to the square root of 4 times 16. So it's equal to the square root of 64, which is 8. For y, remember y is a leg, so it's equal to the geometric mean of 4 times 20, the whole thing. So it's equal to the square root of 80, which is the square root of 16 times 5, which is 4 rad 5. And then for z is a leg as well, and z is going to be the geometric mean between 16 and 20. So 16 times 20 gives you 320, which is the same as 64 times 5, which gives you 8 rad 5. All right, so then for the last one, finding m is a leg. Well, in order to find m, we need to find this part of the altitude. So we know 6 is the geometric mean between 4 and x. So to find x, we square 6, square the square root here, so 36 equals 4x, so 9 equals x. And then to find m, it's the geometric mean between 9 and the whole hypotenuse, which is 13. Well, the square root of 9 is 3, so it's 3 rad 13. All right, that concludes our video on the geometric mean. Part 2 coming up soon.